I think we all agree that JSON deserialization is one of the most common tasks we as developers of Dart and Flutter applications have to perform regularly, which means that implementation efficiency in this area has a significant impact on the overall speed and ease of the development. Yet over and over I see these two pretty common scenarios. Some folks prefer to do JSON deserialization manually, which is more time-consuming and error-prone than using code generation. And second, even if they do use code generation, they'd have these separate data transfer objects or data models with JSON deserialization logic. These classes will be returned from an API layer. And they'd also have corresponding domain models with similar structure, which are used across the application. And then they'd have these mappers that copy data back and forth between data transfer objects and domain models. At best, these mappers also provide default values or change field types, but more often they just copy-paste data between classes over the same structure. Today I will show you what I think is the more efficient way of implementing JSON deserialization, which will suit most of the business Dart and Flutter applications. As you can guess, it involves code generation and excludes mappers. Hi everyone, I'm Anna Leushchenko, Google developer expert in Dart and Flutter from Ukraine. I'm also a Women Tech Makers ambassador and a Flutterista. I currently work as a senior staff engineer in the UK fintech company called Tide, where we create mobile applications for our huge financial services platform using Flutter. I regularly share my practical experience from the world of enterprise Flutter projects, so if you're interested in growing as Flutter developer, make sure to follow me on social media. So, where this inefficiency problem is coming from, especially regarding mappers? Most of the time, developers create them just because clean architecture told us to. Indeed, the objective of this architecture, as with many other layered architectures, is the separation of concerns by dividing the software into layers. Thus, naturally, for better separation, every layer may operate with its own set of models and require mappers to convert models from one layer to another. It sounds reasonable, but in practice, when applied dogmatically, most of the time we end up with having these dummy mappers that just copy-paste data between same-looking objects. When addressing similar concern, Uncle Bob himself said that it was never his intention and that it is fine to pass simple data structures between layers. I believe that it is our developers' responsibility to make a healthy judgment about when a concept should be adopted and when it is an overkill. Clean architecture is great and definitely works, but because it's a general-purpose concept, it may be suboptimal in some scenarios, and I think this is the case for the majority of mobile applications. Another reason developers create mappers is when they do use code generation in data transfer objects, but they are not confident that they can have the same level of control over the incoming JSON structure with code generation in domain models as they can with manual mappers implementation. If there is a change in the data structure received from the backend, we want to minimize required code updates and contain it in the deserialization logic, so that the domain model structure remains unchanged and thus no further updates are required in the business logic layer and above. This is a very important benefit, and I'll show you how to achieve the same result just with less code. For your convenience, I divided this session into 3 distinct parts. In the basic section, we'll set up the project to use code generation with JSON serializable and freezed, and we'll create a Dart class that will accommodate data parsed from a JSON with one-to-one match in regards of field names and types. I'll also show a must-have configuration for JSON serializable in build YAML file. In the intermediate section, we'll start customizing Dart classes created in the basic section for them to be more independent from the JSON they will be deserialized from. We'll talk about changing class field names, types, and structure, ignoring some of them, and providing default values. We'll also talk about serialization of generics and enums. And in the advanced section, I'll address more sophisticated cases like serializing standalone enums and automatically parsing Dart class hierarchy from JSON based on some indicators and without them. Let's get started! The API we're using today as an example, is heavily inspired by the Marvel Comic public API, although there are some differences. This is a JSON representation of a single comics object. It has an integer ID and digital ID, string title and modified date. Next we have a thumbnail, which is an object that represents an image, and an images array of a similar image object structure. Let's now create a Dart class that has a one-to-one match to this JSON structure. Here is what the manual implementation would typically look like. Here we have a Marvel Comic class with corresponding fields and a pretty standard from JSON implementation. We also have a Marvel Image class to represent the image for the comics thumbnail and images array, which can also be deserialized with the from.json constructor. To improve this implementation efficiency, let's now use code generation. We have to add these 5 dependencies to the Flutter project: build runner, JSON annotation and JSON serializable, and freeze annotation and freezed. And we have to run code generation by executing this console command: dart run build runner watch. The output should look similar to this one. Now the project is ready for implementing JSON deserialization efficiently. Here is an updated Marvel Comic class implementation with the freezed package. There are 2 additional part files declared. The class is annotated with the freezed annotation, and then a factory constructor lists all the same class fields. There is also the same from.json constructor declaration. I won't go into details of freezed implementation here, but essentially it created a Dart class that can be used just the same way as when it was a regular Dart class, but it provided a better developer experience because now Marvel Comic conveniently overrides toString, equals, and hashcode methods. As for JSON deserialization implementation, the generated file contains a declaration of both from.json and toJSON methods. Here we have a code very similar to the previously manual implementation. All the standard types are parsed directly, including datetime, and for a custom Marvel image type, its own from.json constructor is used. Lists are also parsed as expected, item by item. Let me now show you the Marvel image class declaration. It's also very similar. A constructor with a list of fields and a from.json declaration. And here is the code that was generated for its JSON deserialization. All the fields, including the URI type, are nicely parsed out of the box. When serializing back to JSON, all class fields are put into a map with the same JSON keys. Back to JSON serialization of the Marvel Comic class, we see that it also puts together a map with all class fields. However, we don't see a call of the 2 JSON methods from the thumbnail field, and also images list is not converted back to JSON. To fix that, we have to create a build YAML file next to the pubspec YAML file of our project and configure this explicit to JSON parameter to true. While we're here, it's also worth configuring include null to be false. Let's now see how the generated code has changed. This is a new implementation of JSON serialization that was regenerated. First of all, the thumbnail field is now explicitly converted to JSON. The same is true for every instance from the images array. And second, now there is a new write-not-null function that will only allow non-null values to be put into the resulting JSON map. Looks much better now. Here I wrote some tests which demonstrate that our generated code implementation of from.json and toJSON methods can correctly handle serialization of all the standard and custom types and collections. Now that we have a freezed JSON serializable class Marvel Comic that represents a one-to-one match to a JSON data format the application is expecting to receive, it is time to adapt it to better fit our business logic implementation rather than backend implementation. Let's start with something easy and allow renaming class fields without depending on the JSON keys. Let's say that it's more convenient for us if the path field of an image is called URL. For that, we have to update the Marvel image class. We add a JSON key annotation over the field that is now called URL and give its name value path. Now, in the generated code, it is the URL field that gets the value obtained from the path JSON key. My personal preference is to always provide names in JSON key annotation, even if the class field name matches the JSON key name. This way, it's easy to avoid bugs when the Dart class field gets accidentally renamed. Next, let's talk about field type changes. Let's say we want both ID and digital ID to be a string rather than an int. For that, we have to create a child of a JSON converter class. Here we provide the type of a value in JSON and in the Dart class. And we have to override from JSON and to JSON methods. Here, from JSON accepts int that comes from JSON and returns a string expected by the Dart class field. And to JSON does the opposite transformation. Now we have to apply this new converter above ID and digital ID fields and change their types from int to string. Let's now see how the generated code changed. Both ID and digital ID values are passed to the converters from JSON methods before being assigned to classed fields. We also see that for nullable fields like digital ID, there are special functions generated that would only trigger a converter if the value was present in the incoming JSON. As you see, converters mechanism is highly generic, which gives you a complete freedom in field types choices. For example, if we wanted to change a thumbnail field type from a custom type Marvel image to just an inner URI, we could create a converter that accepts an entire JSON and returns a URI. In its from JSON, it parses the incoming JSON into Marvel image and extracts its URL. Now we can apply this converter on top of the thumbnail field and change its type to plain URI. This is just one of the ways to make the Dart class structure significantly different from the JSON structure. I'll show more in the advanced section. Sometimes, for some reason, backend developers may implement the API in a way that it throws errors in case some object fields are sent back in JSON. Let's say in our case, they aren't happy to receive back the modified field. It's easy to fix by adding the JSON key notation with include to JSON field set to false. Now, modified field is still being read during JSON deserialization, but is no longer present in the serialization result. It's not a rare case that we'd like to give some field a default value in case it's not present in the incoming JSON. This can be done with the help of the default attribute from Freest. Let's say we want the comics title to be untitled, if no value was sent in JSON. With the current implementation, the deserialization will fail. So here we have to replace the required keyword with the default annotation, and now generated code reads title as a nullable string and provides the untitled string as a fallback value. The most common scenario where I like to provide default values are lists. Currently, images list is nullable, which means whenever I want to access its values, I have to perform a null check. In practice, I don't typically need a distinction between null and empty lists. Thus, I usually just provide an empty list as a default value like this. In reality, Marvel API does not send data right in the root of the JSON response. Instead, it wraps it into a data object and sends it together with other information about the response. And it does so for any other response, so it makes sense to create a reusable generic Marvel API response class. It looks quite similar to other Freest models we declared earlier, but here it has a generic parameter t and declares a field data of this type. Also, the from JSON declaration is different, as now it also accepts a second parameter that instructs how to parse the inner type t. The generated code also looks similar, but it now uses helper functions for inner types deserialization. Here I created a new pair of tests to demonstrate the usage. A from_JSON function of the generic Marvel API response class accepts Marvel comic from JSON, and a generic toJSON function accepts a Marvel comic to JSON. And finally, let's now talk about deserializing enums. Let's say that instead of just a title, the JSON contains an entire details object with a bunch of additional information about the comics. Among others, it has a format field that has one of the predefined values, which we'd want to parse as an enum. For automatic JSON deserialization, let's now create a new Marvel Comic Details model with the format field and a Marvel Comic format enum. The newly generated code contains a map of correspondence between enum values and strings expected in JSON, and strings values were generated directly from the enum item names. Such implementation will not work, as the values that come from the backend have different capitalization, but it's easy to fix by enhancing the enum with JSON value annotation over each item. Now the map in the generated code was changed and uses the exact value as they are received from the API. Now, if over time a new unknown value is returned from the backend, the current implementation would simply crash. We wouldn't want to rush with releasing a new version and forcing user to updates just because of this, right? To address this problem, I always add a new enum item called unknown and specify it in the JSON key annotation above the field with this enum value in unknown enum value property. And I also set it as a default value. Now, whenever the backend sends a new value we are not yet aware of, or if it doesn't send any value at all, the application can gracefully handle this situation. Staying on the topic of enums, I'd like to point out that the serialization logic for the Marvel Comic format enum was generated in the Marvel Comic Details file, because it has a field of this enum type. So if there is no JSON serializable model using such an enum, no code will be generated. However, there are cases where we want enums to serve as an API request parameters, like this sort order enum here. Such enums will not be a part of any model, but we still want them to have the deserialization logic generated. This is easy to do with always create flag of the JSON enum annotation. It also requires adding a part file declaration, where now a similar map was generated, even though the sort order type is not used in any model. Now this map can be used in an enum public method like this. I also would like to point out that if the style of renaming enum items to JSON values is consistent, like here, instead of providing individual names in the JSON value annotation over each item, we can set the renaming field in field rename property, which can automatically convert enum names to kebab, snake, and Pascal case. Take a look at this creators array here. It makes sense for our Marvel Comic Details model to have a field with a list of creators, where all items share a base class, but children have a different set of fields. Editor has only a name, illustrator has a list of illustration numbers, and the writer has a string value with page numbers. When implemented in plain Dart, this class hierarchy may look like this. But since we are talking about efficiency here, this is how the same hierarchy can be implemented with freezed unions. This way, all the subclasses of Marvel Comic Creator also conveniently implement toString equals hashcode and copy with methods, and have pattern matching capabilities. So we have this single from JSON factory constructor, which somehow has to decide which of the subclasses of the Marvel Comic Creator class to deserialize to. In the incoming JSON, each creator's list item has a role field that will help us distinguish between editor, illustrator, and writer. To leverage that to easily parse comics creators to proper subtypes, the Marvel Comic Creator model has to be updated. Now the freezed annotation accepts the union key with the name of the type indicator, in our case it's role, and each union item is annotated with freezed union value, with the name of the role as it comes from JSON. Similar to enums, I recommend adding an unknown item and provide it as a fallback union option in case backend sends us something new. Here is how the generated code was changed. We see that the main from JSON function now looks at a role key in the incoming JSON and based on its value calls from JSON constructors of known subtypes. In case the value is unknown, it falls back to unknown creator subtype. Now the creators list can be added to the Marvel Comic Details model and will be correctly parsed automatically. So far we looked at a case where an indicator about the class subtype was present in the dedicated JSON itself. Let's now talk about the case where such an indicator is not present. Here are several examples of what the metadata JSON field may look like. As we see, the data structure is different and there is no common indicator field. According to our backend, the metadata structure depends on the book format field that is specified outside of the metadata JSON, so the previous approach needs an enhancement. Let's declare a freezed union Marvel Comic metadata with 3 expected child classes and an unknown variation. By default, the generated code looks for the runtime type key in the incoming JSON, so we have to somehow place it there before this code gets called, and in the place where we can make an informed decision about its value. This place is the parent Marvel Comic details model. Here is a new field of type Marvel Comic metadata, which has a default value of unknown subtype, and it is also annotated with JSON key with read value property. This is a special function that gets called before the metadata gets deserialized, and what's important, this function receives not just a JSON dedicated to a metadata, but the parent JSON for the entire details object, together with the format field. So we can read its value here and make a decision about the metadata type. The return value of this function is the JSON dedicated to the metadata field alone. So here I take the original metadata JSON and put the runtime type key in it before returning. Now the deserialization flow continues as normal, and this code inside Marvel Comic metadata class will be able to correctly choose this subtype. Of course, this implementation may be improved by removing code duplication and magic constants and adding error handling, but I hope you got the idea. The read value function of the JSON key annotation is a powerful tool for manipulating incoming JSON structure and hacking it to perfectly fit application needs. Thanks to using code generation and removing data transfer objects, we managed to significantly reduce the amount of code compared to a traditional JSON deserialization approach, but kept leveraging the benefit of being independent from the JSON structure received from the backend. And as for the mappers, I wouldn't say that we completely removed them, but they are now generated right from the domain models thanks to the various annotations. I hope this session was convincing enough for you to try this approach in your Dart and Flutter projects. By the way, if you are interested in code generation in general and what other typical Flutter application development tasks it may facilitate, check out my recent work, Code Generation with Dart and Flutter, the Ultimate Guide, at Code with Andrea platform. Happy fluttering!